Hello class, we are going to go over yesterday's assignment. So we're in chapter 9, this is number 5, 6, and 7. So number 5, they want you to graph each of these graphs and then make observations. You know, how do these graphs change compared to the equations? And also, they basically want you to find the lowest point on the graph, the smallest or the largest output. So I used Desmos to graph these. The first one is x minus 1 squared, so that's the red one. You see the red one right here. So its vertex is at this point, which would be 1, 0. So with an input of 1, you get the smallest output value, which is 0. So you can see from the graph that is its minimum value. That's as low as that graph goes. If you think of its vertical dimension as the y value, this is the bottom of the parabola. And then the next one is this blue graph here. Its vertex is at 0, -2. X plus 2 squared is the green one. Notice, counterintuitively, it shifted left 2 units. So its vertex is -2, 0. And the last one is the purple graph, this upside down one. And its vertex, you should have got 0, 3. So the first one, just to recap, the first one, if you notice, shifted right 1 unit. The blue graph shifted down 2 units. The green graph shifted left 2 units. And the purple one shifted up 3 units. Next problem has you graph these 3 functions. I didn't type in the f of x part on these. It turns out you don't need the y equals when you graph on Desmos. You just need the right side of the equation. Just pretend it's there, it's fine. Okay, so in this one, yeah, they're asking you questions about making observations. So the red one is your basic y equals x squared graph. The blue one, you can see, turns upside down. The reason it's turning upside down is, as you guessed, has a negative coefficient. So if we think about the standard form of a quadratic function like this, if a is negative, then that makes the graph go upside down. So the blue and green graphs are going upside down here. Notice the width of the graphs. We've got just the standard y equals x squared width of the graph, and then the blue one has a -2 coefficient. Notice that one is skinnier. And then the green one has a coefficient of -1/2 or 0.5. And that widens that. And remember, we call that vertical stretching or compressing. If it's getting wider, we call it compression. If it's getting skinnier, we call it stretching. Kind of like when someone grabs your arms when you're a little kid and picks you up, which they shouldn't do because your arms could come out of their sockets. But that's a vertical stretch. Should I draw that? Yeah, let's draw that. Okay, so here's the little kid. Doo-doo-doo. What good are these videos if we can't draw them? Here's his arms, you know, stretching upwards towards the sky. So the higher those arms stretch, more of a stretch they have. Okay, the last problem, really, you should be able to graph by hand a function. We don't have you do that a lot because it's a little tedious, and we have all these fancy schmancy tools like Desmos to graph for us so we can understand the graphs. But really, it's good for you to graph by hand sometimes. So we're going to graph the standard one first, f of x equals x squared. I know how this graph is going to look, so I'm going to pick these values to put in. And it's asking you to take the input of x and square it. So negative 2 times negative 2, or negative 2 squared, is a positive 4. Negative 1 squared is 1. And so on. And then we graph these. The first number is on the x-axis. So for negative 2, 4, we go left 2, up 1, 2, 3, 4. That's 1 point. Negative 1, 1, 0, 0, 1, 1, and 2, 4. 1, 2, 3, 4. Okay, so that's the first one. The second one, what you should do is, hopefully you're familiar enough, or you're getting more familiar with how these changes and what this function looks like affects the graph. And if you want to make a prediction here, let me do a little erasing, make some room here. If you want to make a prediction here, what would you think? Would you think that this graph, compared to the first one we graphed, do you think that graph is going to shift up, down, left, or right? Make a prediction before you start putting numbers in. Okay, because I know how this graph is going to look, just because I've done this so many years, I'm going to start putting some values in like this. And if we plug 0 in here, we get 0 minus 2, which is negative 2 squared, which is positive 4. No, you know what? We should change colors. Let's go to purple. Yeah, let's do that. Okay. Why have black ink when you can have purple ink, is what I always say. Okay, we plug 1 in. 1 minus 2 is negative 1. Negative 1 squared is positive 1. 2 minus 2 is 0. 0 squared is 0. 3 minus 2 is 1. 1 squared is 1. And so on. So let's plot these points on here. 0, 4. 0, 1, 2, 3, 4. 1, 1. 2, 0. 3, 1. 1, 2, 3, 4, 4. 1, 2, 3, 4. And you might say, Mrs. Proust, how did you know what numbers to put in here? Who told you what to put in here? And I'll have to say at this point, my friend, just experience, all right? I looked at that equation. I knew it was going to shift right 2. So I didn't bother putting a bunch of negative numbers in. I could have, but that'd just be so much calculation, and I don't want to spend all that time calculating. So I will teach you how to estimate where these are going to be. So if you do find yourself stranded on a desert island or shut at home in a pandemic and you need to graph a quadratic function, you could totally do it by hand, no technology necessary, because you'll know where to pick these points from. Okay? Good times. This has been your quality quarantined quadratic instruction for the day. So please keep track of our schedule every day on Google Classroom. Do the assignment before I go over it. Okay, you got to try it yourself first, and then you will care about the explanation more. That's how it works. That's how learning works. You got to practice. Okay, I'll give you some instruction, but you got to practice. And you got to ask me questions if you get stuck, all right? So that's the deal. Don't hesitate to post questions on Google Classroom, because if you have the question, guarantee you someone else does too. Okay, goodbye.